Hello students, welcome to the class. So in the previous class, we have discussed around 20 questions. Proceeding to the next set of questions. Here we have the first question, 21st question. In the Haber's process, 30 liters of dinitrogen and 30 liters of dihydrogen were taken for a reaction which yielded only 50% of the expected product. What will be the composition of the gaseous mixture under the aforesaid conditions in the end? So they have taken 30 liters. Haber's process, we know that it is manufacture of ammonia. Gaseous nitrogen, that is dinitrogen, when combines with gaseous dihydrogen, it is a reversible reaction. It forms ammonia in gaseous form. Balancing the reaction comes out to this. So they have said 30 liters of dihydrogen and 30 liters of dinitrogen were taken for the reaction. So here I can say nitrogen, 1 mole of nitrogen, when combines with 3 moles of hydrogen, it gives me 2 moles of ammonia, correct? Yes. So if I divide the whole equation by 2, I'll get 1 by 2, 3 by 2, and 2 by 2 is 1. Okay. So 30 moles of 30 liters of dinitrogen and 30 liters of dihydrogen, they have said. Multiply entire reaction by 10. 10 into 1 by 2, 10 into 3 by 2, and 10 into 1. Okay. This comes out to what? This comes out to 15. This comes out 2 ones are 2 5s are 5 3s are 15. 2 ones are 2 5s are. So this comes out to 5. This comes out to 15. And this comes out to 10. Correct. So composition of the gaseous mixture under aforesaid conditions in the end will be H2, they have said 30 liters minus how much is there? 15. So it will be remaining how much? 15 liters. Yes. N2, they have said 30 liters. But here how much is there consumed? 5. Remaining is 25 liters. And ammonia, they have said 50%. Therefore, 10 liters. 10 liters remains same. Yes. Therefore, what is the correct option? 10 liters of ammonia is there. 20 liters of, okay, 30 minus 5 is 25 liters of nitrogen and 15 liters of dihydrogen is present. Correct? So, which is the correct option? 10 liters of ammonia, 25. So, option B is the correct option. Option B is the correct option. Next question. The reaction quotient Q for the reaction N2 plus 3H2 gives 2NH3 is given by Q is equal to, reaction quotient means what? It is not at equilibrium. Okay, it is not at equilibrium. It is somewhere before equilibrium or after equilibrium. The reaction will proceed from right to left. From right to left. That means it is backward. When it will proceed from right to left. Okay. So let us take the same reaction. They have given this reaction itself. So I'll erase this part and we'll consider the same reaction. Fine. Okay. So what they have said, this is the reaction. Yes. And they have said quotient, reaction quotient for a given reaction they have given. Let us first write Kc. Kc is equal to what? Concentration of NH3 raised to 2 divided by concentration of N2 raised to 1, concentration of H2 raised to 3. Calculate delta N. All are gaseous. So 2 minus 4 is equal to minus 2. That means delta N is negative. Okay. Now what they have said, reaction should go from right to left. See, if this is the equilibrium, okay, let me take it like this. Suppose this is the reaction, how it is happening. This is the progress of the reaction. Okay. Now, if the equilibrium constant, this is equilibrium constant somewhere here. Okay. Now, if QC is less than Kc, QC is less than Kc, then reaction will proceed in which direction? It will proceed in forward direction to reach the equilibrium. If QC is more than Kc, if QC is more than Kc, then reaction will proceed in backward direction. Therefore, they have said from right to left. That is means what? From right to left, the reaction should come. That means it should come in backward direction. And when the reaction will come in backward direction? When a reaction quotient is more than equilibrium constant. Correct? When reaction quotient is more than equilibrium constant. Is the correct option? Option C is the correct option. When reaction quotient is more than the equilibrium constant, right? Next question. Hydrolysis of sucrose is given by the following reaction. Sucrose plus H2O gives glucose plus fructose. This is called inversion of cane sugar also. If the equilibrium constant Kc is 2 into 10 raised to 13 at 300 Kelvin, the value of delta R G naught at the same temperature will be. Okay, so let us solve. What is the given equation? The equation given is sucrose undergoes hydrolysis to give glucose plus fructose. Correct? Glucose plus fructose. It gives glucose plus fructose. Okay. So this reaction is called, what do you know? It is also called inversion of cane sugar. Sucrose is cane sugar. It is also called inversion of cane sugar. Okay. So what they have said, the equilibrium constant is given. How much is given? Kc is equal to 2 into 10 raised to 13. And temperature is 300 Kelvin. Okay. So let us, what they have asked, value of delta G naught. Therefore, I can write the equation. I know that delta G is equal to delta G naught for the reaction plus RT ln QC we take actually. At equilibrium, what will be QC at equilibrium? At equilibrium, QC will be equal to Kc. Therefore, I can substitute QC by Kc and I write delta G is equal to delta G naught of the reaction plus RT ln Kc. Correct? Can I use this equation to find delta G naught? Delta G naught is equal to delta G is what at equilibrium? Gives free energy at equilibrium. Delta G is equal to 0. Therefore, this is 0. Yes or no? This is what? This is 0. So 0 is equal to this. Therefore, delta G naught is equal to what? Minus RT ln Kc. What is the value of R? Minus is there 8.314 into temperature is 300. Yes, the unit here is joules per Kelvin per mole. The temperature is 300 Kelvin into what is the value of equilibrium constant? 2 into 10 raised to 13. Ln of 2 into 10 raised to 13. Yes, this equation is asked in the same format. So what is the correct option? The correct option is option delta G naught is equals to minus 3.303 RT log K. Yes, so this is the correct option. When you remove ln, you will introduce the term 2.303. Yes, okay. Next question. Which of the following statements, which one among the following conditions will favor maximum formation of the product in the reaction? Reaction is given A2 plus B2 gives X2 and delta H is a negative. We have studied according to what? According to Le Chatelier's principle. According to Le Chatelier's principle, the reaction given is what, students? It is A2 gaseous plus B2 gaseous will give AB, they will give X, they have said. It will give X2 and delta H is equal to minus X kilojoules. So some amount of energy is released. Delta H is negative means what? It is exothermic. And we know that for exothermic reactions, if you increase the temperature, on increasing the temperature, yes, equilibrium will shift in backward direction, correct? So can I say I want to shift it in, I want more yield means what? I have to get X2 more means reaction should shift in forward direction. So decreasing the temperature, reaction equilibrium will shift in forward direction. Okay, this is for temperature, first one. Second one for pressure. Let us see delta N. All are gaseous, all are being given in gaseous form, correct? So let us calculate delta N. It is equal to 1 minus 2, that is minus 1. So delta N is negative means what? Delta N is less than 0. So what we should do? On increasing the pressure, equilibrium will shift in what? Equilibrium will shift in forward direction. So what are the two conditions? On increasing, let me write it like this. On increasing the pressure and decreasing the temperature, equilibrium will shift in forward direction. Yes. So when it is shifting in forward direction, it will give me what? It will give me more yield of the compound. Yes. So which is the correct option? Low temperature, high pressure. Yes. Option A is the correct option. Right. Next, match list 1 equations with list 2 types of the processes and select the correct option. Okay. Kp is more than Q. Delta G naught is less than RT ln Q. Kp is equal to Q. T is more than delta H upon delta S. And here they have given non-spontaneous, equilibrium, spontaneous, and endothermic and spontaneous. Okay, fine. So see what is being asked, we need to understand here. First equation you just see. Look at the first equation. They have said Kp is greater than Q. Okay. When Kp is greater than Q, that means equilibrium constant it is. In terms of partial pressure, it is more than Q. That is reaction quotient. Therefore, I can say rate of, in this case, forward reaction is more than rate of backward reaction. Correct? Rate of forward reaction is more than rate of backward reaction. Therefore, what I can say here? Therefore, I can say the reaction is spontaneous. The reaction is spontaneous. This is first explanation. Yes. Second explanation is they have said delta G naught is less than RT ln Q. So what does this explanation give us? When delta G naught is less than RT ln Q, that means what? Delta G naught is positive. Delta G naught is positive. So when delta G naught is positive, reverse reaction is feasible. Yes, reverse reaction is feasible. Reverse reaction is feasible. Thus, when reverse reaction is feasible, what we say? Reaction is non-spontaneous. Reaction is non-spontaneous. Correct? Reaction is non-spontaneous. Third one, they have said Kp is equal to Q. Kp is equal to Q means what? That means rate of forward reaction is equal to rate of backward reaction. That means it is at equilibrium. Rate of backward reaction. So it is at equilibrium, right? Therefore, what is the conclusion? Therefore, reaction is at equilibrium. Reaction is at equilibrium. And what is the last option? Last option says T is more than delta H upon delta S. What does this mean? We know that the equation is delta G is equal to delta H minus T delta S. So here we have something T delta S. So when T delta S is more than delta H, T delta S is a negative value. What happens? Delta G will become, since T delta S is negative, delta G will become negative. Yes, delta G will become negative only when delta H is positive. Delta G will become negative means what? That means the reaction is spontaneous because delta G is negative, and delta H is positive means what? It is endothermic. It is endothermic. So from all these we get these explanations. So Kp is more than Q means reaction is spontaneous. This equation means reaction is non-spontaneous. This means reaction is at equilibrium, and this means reaction is spontaneous and endothermic. Correct? Reaction is spontaneous and endothermic. So which is the correct option? So we will take it here. Okay. So Kp is greater than Q. So which holds good? So it is spontaneous. Then delta G naught is less than RT ln. So it is non-spontaneous. Correct? Kp is equal to Q means what? It is at equilibrium. And T delta S, T is more than delta S upon delta H. Sorry, delta H upon delta S. It is spontaneous and endothermic. Correct? So which option holds good? For A, it is 4. Yes. So it is only third one. B, it is 1. Yes. C, it is 3, 2. And D, it is 3. Is that understood? So this is how we are going to answer the question. Next one. For the reversible reaction N2 plus 3H2 gives 2NH3 plus heat. The equilibrium shifts in forward direction. How? By increasing concentration of NH3, by decreasing pressure, by decreasing the concentration of N2 and H2, and by increasing the pressure and decreasing the temperature. See, as you want to increase what for the reversible reaction, equilibrium should shift in forward direction. So as the forward direction, if you see, heat is liberated, that means delta H is what? It is negative. So as the forward reaction is exothermic, correct? As the forward reaction is exothermic and leads to lowering of the pressure, because see here, how many moles of reactants are there? There are 4 moles of reactants and there are only 2 moles of product. So when number of moles of product decrease, the pressure decreases. Yes, therefore here what I can say, yes, we will take a slide itself better to make you all understand. Okay, so if you look at this reaction, N2 plus 3H2 gives 2NH3 plus heat. So heat means what? Heat means delta H is negative means what? It is exothermic. Exothermic. And if you see here, number of moles of reactants are 4. Number of moles of product are 2. Delta N comes out to minus 2. Correct. So in the reactants, there are 4 moles. And in the product, there are 2 moles. So how much pressure will be exerted by these molecules? And here, so as the number of moles of product decrease, the pressure also decreases. Therefore, what I can say here is, as the forward reaction is exothermic, yes, as it is exothermic, and it is leading to what? Leads to lowering of pressure. Correct? Lowering of pressure. So you can apply what? According to Le-Chatelier's principle, what we can say? According to Le-Chatelier's principle, at high pressure and low temperature, the given reversible reaction will shift in what? Equilibrium will shift in forward direction. It will shift in forward direction. Yes, high pressure and temperature must be low. So if delta N is negative, we have seen increase in pressure shifts the equilibrium in forward direction. Yes, and if reaction is exothermic, decrease in temperature shifts the reaction in forward direction. Is that right? So this is the understanding. So what is the question they have said there? Is it by increasing the concentration of NH3? No. When you increase the concentration of NH3, it will shift in backward direction. Yes. By decreasing the pressure. Is that right? No. Because if here the pressure is already decreasing. By decreasing the concentration of N2 and H2. No. If you decrease the concentration of N2 and H2, again the equilibrium will shift in backward direction. Increasing the pressure and decreasing the temperature. That is the correct option. Yes. Okay. For the given exothermic reaction Kp and K prime P are the equilibrium constants at temperatures T1 and T2 respectively. Assuming that heat of a reaction is constant in temperature range between T1 and T2, it is readily observed that, okay, there is an endothermic reaction, they say. Yes. So for endothermic reaction, they have given two equilibrium constants, Kp and K prime P. I can write it like this. Log of K prime P, that is K2 you can say, upon K1. Yes, we know this equation. In thermodynamics we have seen, is equal to minus delta H upon 2.303 R 1 by T2 upon 1 by T2 minus 1 by T1. This is what we know. Correct. So for exothermic reaction, what happens? Delta H is negative. That means heat is liberated. Correct. Heat is liberated. The temperature T2 is higher than T1. Yes or no? T2 is higher than T1. Thus, I can say 1 by T2 minus 1 by T1 is a negative value because T2 is more than T1. It is negative value. Is that right? So, log of K prime P minus log of Kp will be what? Since this entire thing becomes negative, yes, what it will be? It will be minus, that is negative. Or I can say log of Kp is more than log of K prime P. Or Kp is more than K prime P. Is that understood? Clear with this? Yes. So this is the explanation. This is the explanation. So what is the given option? Kp is more than K prime P. Option A is the correct option. Next question. KMnO4 can be prepared from K2MnO4 as per the reaction 3MnO4 minus 2 plus 2H2O gives 2MnO4 minus plus MnO2 plus 4OH minus. The reaction can go to completion by removing the OH minus ions by adding water. So they have given here options CO2, SO2, HCl and KOH. See, if you look at these options, HCl and SO2, these are what? These are reducing agents. What they are? They are reducing agents. So they can reduce, so I'll say they can reduce MnO4 minus because they are reducing agents. If you look at CO2, it is neither reducing nor oxidizing. So it is neither reducing nor oxidizing in nature. It will provide only acidic medium. Why you would need to use it? It will provide only acidic medium because carbon dioxide is acidic oxide. It will provide only acidic medium. Yes. So it can shift the reaction in forward direction and the reaction can go for completion. Reaction can go for completion. So this is the correct option. And KOH cannot be used at all because it dissociates into K plus and OH minus ions. Therefore, carbon dioxide can be used as a agent to shift the reaction to completion. Yes. Next question. The value of delta H for the reaction X2 plus 4Y2 gives 2XY is less than 0. Formation of XY4 will be favored at. So it is less than 0 means what? Less than 0 means it is negative. Correct? So reaction is X2 plus Y2 gives XY4. And what are the coefficients? Here 4Y and here it is 2. Correct? Yes. So they have said, let us see what is delta Ng, gaseous moles. 2 minus 5, it is minus 3. So delta Ng is negative. And they have said delta H is less than 0. That means delta H is also negative. So see, delta N is negative, delta H is negative. So for forward direction, if you want, for forward direction, delta H is negative means it is exothermic. So when it is exothermic, decrease in temperature favors forward direction. And delta N is negative means what? Increase in pressure. So at low temperature and high pressure, the reaction is favored in forward direction. It is favored in forward direction. So low temperature and high pressure. Option D is the correct option. Low temperature and high pressure is the correct option. Is that right? Okay. Next question. For the reaction CH4 plus 2O2 gives CO2 plus 2H2O. Delta H for the reaction is minus 170 0.8 kilojoules per mole. Which of the following statements is not true? The reaction is exothermic. At equilibrium, the concentrations of CO2 and H2O are not equal. The equilibrium constant for the reaction is given by CO2 upon CH4O2. Addition of CH4O2 at equilibrium will cause the shift in the reaction to the right. Now see, this is the reaction. Delta H is negative means what? Reaction is exothermic. Correct. At equilibrium, the concentrations of CO2 and H2O are not equal. Yes, product concentration need not be equal. So that is the correct statement. The equilibrium constant for the reaction is given by CO2 bar CH4O2. See here, they have given Kp. So what is the equilibrium constant for Kp? It should be in terms of partial pressures. Partial pressure of CO2. This is liquid, I will not consider. Partial pressure of CH4 into partial pressure of O2 raised to square. Correct? This is the correct equation. So this is the wrong statement. That is the correct option. Addition of CH4 or O2. That means when you add reactants, equilibrium will shift to a right. Yes. Increase in concentration of the reactants, equilibrium will shift in forward direction. So that is also correct statement. So which is not correct, they have asked. Option C is the not correct statement. Is that right? Next question. Reaction barium oxide gives barium peroxide gives barium oxide plus O2. Delta H is positive. In equilibrium conditions, pressure of O2 depends on. See, when we see such reactions, equilibrium condition they have said, pressure of O2 depends on what? Look at the reaction. It is barium peroxide giving barium oxide and O2. Pressure of O2, if we see in this reaction particularly, the pressure of oxygen does not depend on concentration. Yes, concentration terms of other reactants, because Both, if you see, both the reactants are in solid state. Barium peroxide is also solid and barium oxide is also solid. Yes. And if you see the reaction, delta H is positive. Since delta H is positive means what? Since the reaction is endothermic. Since the reaction is endothermic, increase in temperature, what will happen? Dissociation of barium peroxide would occur and more O2 will be produced. Yes, more O2 will be produced at equilibrium. So what happens if more O2 is produced at equilibrium? Pressure increases. Pressure increases. So increase the temperature on equilibrium. The pressure of O2 depends on what? It depends on increasing temperature on equilibrium. Because if you increase the temperature, pressure will increase and therefore pressure of what? Pressure of O2 will increase. Yes, is that clear? So C is the correct option. For any reversible reaction, if we increase the concentration of the reactants, then the effect of equilibrium constant. Yes. If I say I have A moles of A plus B moles of B, which is a reversible reaction giving me C moles of C plus D moles of D, I will write the equilibrium constant as molar concentration of C raised to C into molar concentration of D raised to D upon molar concentration of A raised to A into molar concentration of B raised to B. Correct? This is how I write. According to Le Chatelier's principle, when you increase the concentration of reactants or decrease the concentration of products, equilibrium will shift in forward direction. Equilibrium will shift in forward direction. Yes, giving me more products. So that equilibrium constant value remains constant. Equilibrium constant, this equilibrium constant value will not change. It remains constant only. It remains constant only because it is independent of concentration. Independent of concentration. So which is the correct option? It remains unchanged. Equilibrium position will shift, not the equilibrium constant value. Getting my point? Equilibrium position will shift, but equilibrium constant value doesn't get unchanged. So it remains unchanged. Is that okay? Fine. According to Le Chatelier's principle, adding heat to a solid and liquid in equilibrium will cause. Okay, let us see. This is a application of Le Chatelier's principle in physical equilibrium. Okay, so we will write here. We have solid and which is in equilibrium with liquid. Okay, so when solid and liquid are in equilibrium, increase in temperature results in what? Increase in temperature results in increase in the volume. Correct? We have seen this results in increase in volume of what? Volume of our liquid. Correct? Or decrease in amount of solid. Yes or no? Getting my point? When you increase the temperature, the amount of solid gets decreased or the volume of liquid gets increased. Therefore, with increase in temperature, I can say with increase in temperature, equilibrium will shift how? Equilibrium will shift in forward direction. Correct? It will shift in forward direction. For solid liquid equilibrium, it will shift in forward direction. Is that clear? Yes. So which is the correct option? Temperature to increase, temperature to decrease, amount of liquid to decrease, amount of solid to decrease. So amount of solid to decrease is the correct option, right? Which of the following information can be obtained on the basis of Le Chatelier's principle? Dissociation constant of a weak acid, entropy change in the reaction, equilibrium constant of the reaction, shift in the equilibrium position on changing the value of the constraint. See, according to our Le Chatelier's principle, Yes, we know this principle. We must know all the criteria of this principle, right? According to Rechartrial principle, if the system in equilibrium, yes, what we say, if the system in equilibrium is subjected to a change in concentration, or you say pressure or temperature, etc. Many changes are there. Equilibrium will shift in such a way so as to nullify, or you can say undo, or you can say reduce, or you can say counteract the effect of change imposed. Correct? So whatever change has been occurred by changing the concentration or changing the pressure or changing the temperature, to nullify the effect of that change, equilibrium will shift in that direction. Therefore, which obtained on the basis of Le-Chatelier's principle. Is it dissociation constant? No. Is it entropy of the change in the reaction? No. Equilibrium constant? No. Shift in the equilibrium position on changing the value of a constraint. Yes, there will be shift in the position of the equilibrium. And why there occurs a shift? Because to counteract on that effect, which is effect of change which has been caused. Yes, so option D is the correct option. Option D is the correct option. Next question. Aqueous solution of which of the following compounds is the best conductor of electric current? Hydrochloric acid, ammonia, fructose, acetic acid. See, they have given us some options here. So let us consider hydrochloric acid, HCl, then ammonia, NH3, then fructose, C6H12O6, and acetic acid. They have given it as C2H4O2. I can write it as CH3COOH. Okay. If you look at all these, suppose if I take 1 mole of HCl molecules, yes, all these 1 mole of HCl molecules will dissociate completely to give me 1 mole of H plus ions and 1 mole of Cl minus ions. Getting my point? None of the molecules will remain. So I'll show this arrow mark. There is no amount of reactant left. Ammonia does not undergo dissociation. Yes, so I will not have any ions. Even this fructose cannot dissociate. It will not dissociate. Whereas acetic acid, if you see, if I take 1 mole of CH3COH, it is a weak acid. Okay, so it will dissociate to give me CH3COO minus, which are called acetate ions, plus H plus. I cannot expect all 1 mole. Hardly 70% have dissociated to give me 70% of acetate ions and H plus. And remaining 30% have remained undissociated. So what I speak here is, I speak about complete dissociation. Yes, you can say dissociation for this, or you can say ionization. So complete dissociation or ionization occurs here, and here it is partial dissociation or ionization. It is partial dissociation or ionization. Getting my point? So which will conduct electricity, best conductor of electric current? So if you pass current here, try to put a bulb and see whether the bulb glows or no. The bulb glows very brilliantly here. The bulb glows very brilliantly here. In the similar way, if you put here, the bulb will glow. It will glow faintly because there are less number of ions, right, which will carry charges. And here there are almost complete. And in these two cases, the bulb will not glow only because there are no ions only. To carry the electric current in these solutions, ions become the charge carriers. Ions become what? Charge carriers. Therefore, where it is the best conductor of electricity, HCl being the strong acid, it dissociates completely into ions in the aqueous solution. Okay. Next question. Aqueous solution of acetic acid contains. See, similar question. As soon as they say aqueous solution, we'll come to direct conclusion. And we say acetic acid is CH3COOH. Its aqueous solution, when you take aqueous solution of it, it will have CH3COO minus and H plus. Immediately we come to this conclusion. But acetic acid is what? Acetic acid, its IUPAC name is ethanoic acid. Okay, its IUPAC name I'll write here. Ethanoic acid. It is a weak acid. So since it is a weak acid, it will undergo what? Partial dissociation. It will undergo partial dissociation. So I cannot expect all the molecules to dissociate and form CH3CO minus ions in aqueous medium and H plus. Therefore, if you see in the solution, it will not only contain CH3COO minus ions and H plus ions, but it will also contain undissociated CH3COH molecules. These are called what? Undissociated molecules, which have not dissociated. Therefore, I don't show the arrow mark straight like this. Instead, we show the arrow mark like this. Because the dissociated ions and undissociated molecules, they exist in what? They exist in equilibrium here. They exist in equilibrium. Is that clear? Yes. So it will contain what? It will contain CH3CO minus and H plus is written as H3O plus. Correct? And CH3COOH. Correct? Okay. Conjugated base for Bronsted acids H2O and HF are. How do you write conjugate acid base pair? So we know if it is an acid and you want to write conjugate base, what you will do? You will remove one H plus. And if it is a base and you want to write conjugate acid, then what you will do? You will add one H plus. It becomes conjugate acid. Correct? So they have said the Bronsted acids are there. Bronsted acids means what? They give protons. So H2O and HF. So what are the conjugate bases for this? Conjugate bases. For H2O, conjugate base is what? OH minus. For HF, conjugate base is what? F minus. So OH minus and F minus are the conjugate bases for H2O and HF respectively. Option D is the correct option. Is that understood? Okay. Which of the following cannot act as both Bronsted acid and Bronsted base? So neither it acts as Bronsted acid nor Bronsted base. Now, what do we mean by Bronsted acid? Bronsted acid is what? It donates proton. Therefore, we call it as a proton donor. Correct? And Bronsted base is what? It accepts a proton. Therefore, I call Bronsted base as proton acceptor. So HCO3 minus, it can donate proton and form H plus CO3 minus 2, or it can accept proton and form H2CO3. It can donate as well as accept. Correct? So I'll take examples here. Let us take it like this. So they have given options. So here, these are all about that theory itself. So Bronsted acid means what? Bronsted acid means proton donor. Proton donor. And Bronsted base means proton acceptor. Correct? Okay, fine. So here, okay. And this also I have to write it here. If you want to write as if acid is given, if you want to write conjugate base, remove one H plus. And if base is given, if you want to write conjugate acid, add one H plus. Okay. Now here what we are discussing is which of them is neither a conjugate acid nor a conjugate base. Option A is HCO3 minus. If this HCO3 minus has to be an acid, that means it should donate proton. And it will become CO3 minus 2 plus H plus. So it is acid. If it has to be a base, it should accept proton. It will accept proton and form plus H plus H2CO3. Okay. Second option, NH3. So NH3 will donate proton and form NH2 plus. It will donate one proton. Yes. Similarly, NH3, it will become NH2 minus. NH3 will accept one proton and become NH4 plus. So it is Bronsted base as well as Bronsted acid. Then HSO4 minus you see. HSO4 minus will donate one proton and become SO4 minus 2 plus H plus. Whereas HSO4 minus will accept an proton and become H2SO4. So these are what? These are protogenic as well as protophilic. Protogenic as well as protophilic. That means they are proton loving also. They will accept the proton as well as they will donate the proton also. Okay. Now here, if you look at the example of HCl, HCl can be Bronsted acid only. It can donate a proton and form H plus Cl minus, but it cannot accept a proton. Therefore, it cannot be Bronsted. It cannot be Bronsted base. It cannot be Bronsted base. Yes, is that right? So it cannot be Bronsted base. So HCl cannot be Bronsted base. Okay. Next question. Which of the following fluoro compounds is most likely to behave as Lewis base? BF3, PF3, CF4, SiF4. Okay. Now, according to Lewis theory, so here, according to Lewis theory, what is Lewis acid? It is electron pair acceptor. Correct? Acceptor. And what is Lewis base? It is electron pair donor. Is that right? So when I say electron pair acceptor is Lewis acid, that means it is electron deficient. Electron poor, you can say. Or it is can be a electrophile. Electron loving. And Lewis base electron pair donor means it is electron rich, or it can be a nucleophile. Okay. So here they have given us options. The options given are BF3. If you look here, BF3, the central atom, that is boron, it is having only 6 electrons. Therefore, it is what? It is having incomplete octet. Incomplete octet. Therefore, this can be what? Lewis acid. Next example, PF3. Yes, here phosphorus, the central atom, has lone pair of electrons. Yes, on phosphorus atom. Therefore, it is what? It is Lewis base. Okay, it is Lewis base. Then CF4, if you see, it is having complete octet. So neither it is Lewis acid nor Lewis base. And SiF4, it is Lewis acid. Yes, because it is having empty d orbital, which is having empty d orbital in silicon atom. Silicon atom. It is having empty d orbital. So which is the correct option? Which is Lewis base, they have said. So which is the Lewis base? It is PF3 molecule. Phosphorus trifluoride molecule. Correct? Next one. Which of these is least likely to act as Lewis base? Lewis base means what? Electron pair. Lewis base. Electron pair donor. So it should give electrons, means it should be electron rich. We know BF3 is electron deficient. Yes, therefore it acts as what? It acts as Lewis acid. BF3, it is electron rich, it will donate as lone pairs. Even CO is electron rich, oxygen has got 2 lone pairs, so it will donate. Fluorine, yes, that is also electron rich. Therefore, BF3 being electron deficient molecule, it does not act as Lewis base. Instead, it acts as Lewis acid. Next question. Which is the strongest acid among the following? HClO4, H2SO4, H2SO4, H2SO3, and HClO3. See, when such options are there, I have discussed with you all how to say about the what you say, as strongest acidic nature, where oxidation number is highest. First is which is most electronegative atom. And second one is where oxidation number is highest. Where oxidation number is highest. Okay. Options given are HClO4, then HClO3, then H2SO3, and H2SO4. Okay, so we'll calculate the oxidation states of chlorine in first examples and oxidation state of sulfur. So first example, HClO4. So it is 1 plus X plus minus 2 it is. So 8 minus 8 minus 7. So here chlorine is plus 7. Okay, in this case, second one I will see HClO3. Okay, so here plus 1, 3 to the 6. Here it is plus 5 chlorine. Okay, so chlorine here is plus 5. Then H2SO4 we'll see H2SO3 first. Okay, so it is 2 plus X minus 6. So 6 minus 2 is 4. So sulfur is plus 4. And H2SO4, 2 plus X minus 8, 6, it is plus 6. So among these two, this is the strongest acid I can say. And among these two, this is the strongest acid. When I compare HClO4 with H2SO4, which becomes strongest? Chlorine is more electronegative, correct? Chlorine is more electronegative than the electronegativity of chlorine is more than electronegativity of sulfur. Therefore, I can conclude saying this is the strongest acid among the following. Is that understood? It is the strongest acid among the following. And its oxidation state is what? Highest, plus 7 oxidation state is there. So HClO4 with the highest oxidation number and its conjugate base when you write ClO4 minus, it is resonance stabilized. Hence, it is strongest acid or most acidic. And chlorine being more electronegative than sulfur, HClO4 perchloric acid we call it as. Perchloric acid is more acidic than sulfuric acid. Yes, next question. Which one of the following molecular hydrides act as Lewis acid? So Lewis acids means what? They are electron pair acceptors. Lewis acids are electron pair acceptors. Okay, so in molecular hydrides, we have different types of molecular hydrides. Among those, if you see electron deficient hydrides, which do not have octet configuration, electron deficient hydrides, they will accept the lone pairs of electrons and they become Lewis acids through coordinate bond. So which is the correct option? Is it ammonia? Ammonia, nitrogen has 1 lone pair. Water, oxygen has 2 lone pairs. Yes, and here ammonia, CH4, it has complete octet configuration. Whereas B2H6, what is B2H6? It is diborane. It is electron deficient because I have explained you the structure of diborane, right? So the two boron atoms we have, and each boron is having terminal hydrogens, 4 bonds there are, and these two are bridging, wherein there is 2 electron, 3 centered bonds. So diborane is what? It is a molecular hydride which acts as what? Which acts as Lewis acid. Yes. Next question. Which of the following molecules act as Lewis acid? Lewis acid are what? Lewis acids are electron deficient molecules. So where there is electron deficiency? Oxygen, there are 2 lone pairs of electrons. Phosphorus, there is 1 lone pair of electron. Nitrogen, there is 1 lone pair of electron. Boron is electron deficient because it is not having octet configuration. It does not have octet configuration. Instead, it has what? It has only 6 electrons, sextet configuration we say. And because of this, we call it as incomplete octet. Sextet configuration is called incomplete octet. And therefore, this can act as what? This can act as Lewis acid. It can act as Lewis acid. Next question. Which one of the following statements is not true? Among halide ions, iodide is the most powerful residue-reducing agent. Fluorine is only halogen that does not show a variable oxidation state. HOCl is stronger acid than HOBr. HF is stronger acid than HCl. So here, which of the statement is not true? First option among halide ions, iodide ion is most powerful reducing agent. As you go down the group, metallic nature increases and metals are acting as reducing agents. Therefore, iodide ion is the best reducing agent. This statement is correct. Fluorine is the only halogen that does not show variable. Yes, fluorine has only -1. Whereas chlorine can show -1 or it can show +1 also. Yes, +2, +3 it can show. But only fluorine doesn't show variable oxidation state. That is also correct. HOCl is stronger than acid than HOBr. Yes, because chlorine is more electronegative than bromine. Therefore, HOCl is a stronger acid than HOBr. HF is stronger acid than HCl. That is not possible because in case of HF, there exists intermolecular hydrogen bonding. Yes, because of this intermolecular hydrogen bonding, the hydrogen is not free. So proton is not given off easily. So this H plus is not given off. Given off easily. Yes, therefore HCl is stronger acid than HF. Yes, though the bond length is less in HF than HCl, because HF can form intermolecular hydrogen bonding. Because HF can form intermolecular hydrogen bonding, a proton cannot be lost or given off very easily. And where H plus is given very easily, that becomes a stronger acid. Therefore, I can say HCl is a stronger acid than HF. Which of the following compounds is not a protonic acid? BOH thrice, POOH thrice, SOOH twice, and SO2OH twice. Okay. If you look at the first option, BOH thrice, in aqueous medium, it coordinates a water molecule to form hydrated species. Like it will coordinate with water molecule. Yes, and forms hydrated species because boron is electron deficient. Okay. Yes. So in this species, B plus 3 ions, in this species, the B plus 3 ions which are there, because of their small size, they have high polarizing power. So due to small size, they have very high polarizing power. Okay. Thereby, they pull the sigma electron charge of the coordinated oxygen atom towards itself. They will pull it towards itself. Yes, the coordinated oxygen atom in turn pulls the sigma electrons on the charge of OH bond, which are attached to the water molecule. This facilitates removal of H plus ion from the OH bond. Removal of H plus ion from the OH bond. So we can show it like this. H, O, H, and this is coordinated with B, O, H thrice. We can write it as B, O, H 4 times minus plus H plus, which is not possible in any of these 3 cases. Thus, the solution of BOH thrice in water acts as weak acid, and it is not protonic acid. It is not protonic acid. Is that right? Okay. In HS minus I minus R minus NHR, okay, NH2, NH3, order of proton accepting tendency will be. Okay, let us see. So they have given us the options. Let us go one by one. Proton accepting tendency means what? Proton accepting tendency is known as strength of basicity. Strength of basicity. Okay. So if you see RNH2, it is what? RNH2. Okay. Here, nitrogen has got lone pairs of electrons. Yes, which intensify due to electron releasing group of R. So R is electron releasing group, so it will release electrons. So this lone pair of electrons intenses, yes, and increases the tendency to donate the hydrogens, H plus ion. Secondly, as the size of the ion increases, as size of ion increases, what will happen? Attraction for H plus ions to form bond with hydrogen, yes, there is less attraction, decreases. Yes, as the size of ion increases, attraction for H plus to form bond decreases. And therefore, we say they are less basic. Yes, thus the order follows. I'll write it here. RNH2 with lone pair is most. Then we have NH3. Then we have HS minus. And then we have I minus. This is the correct order. Yes, understood. So here, this is more, has the tendency to accept proton more than ammonia, because here all 3 are hydrogens, but here it is R group. So R, what it will do, it will donate its electrons. So when these electrons become more intense, hydrogen can come and attack more easily. When you look about sulfur, the size of nitrogen is smaller than that of sulfur. Therefore, as small size decreases, attraction becomes more, so it will add up easily. Therefore, HS minus comes next. Iodide has got larger size. Yes or no? So this is the correct order. This is the correct order. So which is the correct option? The correct option is option RNH2, NH3, HS minus, and iodine. Iodide ion, I'm sorry. Yes. So we have discussed some set of questions again. We have still more, lot many questions to discuss. We'll discuss them in the next class. Hope you have followed all the questions till now. Please practice the concepts so that again, when we are solving the next set of questions, it becomes easy for us. For now, thank you.